balloon here. Do you know what would happen if I rubbed it on the sofa, the fabric right here, and then put it close to my head? What do you think would happen?
Your hair will stick up.
My hair would stick up? And do you have any idea why? Well, let's do it first. Let's check it out first. Okay, so I rubbed the balloon, and now I'm putting it against my hair, and I can see in the mirror over there that my hair is really, what's it doing? Sticking to what?
A balloon.
So my hair is,
Static.
it's got static because it's attracted to the balloon. My hair is attracted. Is it still sticking up? Okay, so we're talking about static. And my hair was attracted to the balloon, right?
Mm-hmm.
Does anybody know why? Can you tell me why my hair might have been attracted to that balloon? Why it's standing up all by itself? So let's draw a picture. Okay? Got a balloon, and we're going to say it's got positive charges. Because it got any extra charges when I rubbed it on fabric, right? And then we've got my hair. What type of charges do you think my hair might have? Let's say my hair has negative charges all around it, and the balloon has more positive charges. So that's going to make them attract. They are going to be attracted to each other because of the positive charges and the negative charges. They attract. Okay? So, let's go on that. But see my hair afterwards? It's like it's trying to go back down real quickly. So, if we have hair that has negative charges, we're just picking one because we don't know exactly which one it is. And I've got hair that has negative. So two negatives, they're going to what? A negative or positive attract. Negative and a negative are going to what?
Separate.
Separate, right. That's a good word. So they're going to separate. They're going to each want to go back to where they were. Or as you said, separate. Okay? So, okay. So what is this called? It's called static electricity. Static electricity, okay. So, we saw the balloon, rubbing the balloon, and you guys seeing my hair go all over the place. Can you give me another example of static electricity that you've seen? At all? Anybody? Have you ever gone across the rug real fast? What happens if you go up for a rug real fast? I used to do this with my brothers when I was little, and when you touch them, what happens?
You get shocked.
You get a shock. So, static can cause shocks. Yes, my spelling is not very good today. And there's my handwriting. So what else? Something else. What happens, have you ever had your mom or grandma or somebody get clothes out of the dryer?
When they touch it, when they touch the clothes, it shocks.
It can. It really can. But what's something else? Have you ever gotten out a shirt and seen something really stuck to it?
Oh,
Like a sock stuck to your shirt? And it makes that crackling sound when it comes off. So let's let's talk about that sock. That sock, when it's stuck to you, actually you can see it right there. See, it's stuck to it. When it's stuck, the sock is stuck to the fabric. Which one is that? Is that two negative charges or a negative and a positive when it's stuck together?
Negative and positive.
Negative and positive, very good. And probably when you're shuffling it along and you zap your brother or your cousin or somebody.
The shocks,
What?
it's like on a trampoline when you rub your feet.
Yes, on a trampoline when you rub your feet because you've got your socks on. Have you ever done that in the gym? Yeah, okay. So another one's trampoline. I like that. Trampoline with socks. Okay, very good. Okay, so now we were talking about, let's go back to this. So when it's stuck together, it is
Static and
It's-
positive.
yeah, positive and a
Negative.
okay. And when it's trying to separate, it's either two
Positive
or
or negative.
two negatives. Okay, great. Okay, so you guys do a good job with that. I think we understand this. So now the fun begins. You guys are going to be scientists. And what you're going to do is I've got 3 stations set around the kitchen. Okay? Experiment number, and if you guys ever didn't fill out data sheets when you're in science classes at school, so these data sheets are really simple. What I want you to do first is I'm going to give you there's a lines here for you to write your hypothesis. Do you know what a hypothesis is? Oh, come on. I know you guys know what hypotheses are. What is a hypothesis? Hypothesis is something you're going to guess what you think might happen, okay, when you do these experiments. So that's the first thing you're going to do. And the second thing you're going to do is at each station you're going to find a balloon, okay, and a towel. I use towels. So you're going to rub the balloon, and then you're going to try and pick up whatever's at the station that you're at, okay? And you're going to do this at least 3 times, okay? And then you're going to put, like on this first one, it's salt and pepper. So you're going to put the movement, which moves more, salt or pepper, okay? And then you're going to write the results and what you thought about it, okay? At the second station, we have paper. So what you're going to do again, you're going to hypothesis, what do you think is going to happen, okay? And then you're going to have test 1, 2, and 3, and then you're going to tell me if you pick up any paper with the balloon or if you don't pick up any paper. And then we're going to put your results, just an idea of what you think happened. See if it matches your hypothesis, okay? And the third station is Rice Krispies. No, you cannot eat the Rice Krispies yet, okay? No eating the experimental stuff. I don't think you'd really want to eat salt and pepper by itself, but just in case. No? Okay. So what I'm going to do is we're going to go out to the kitchen, and each person just go to one station. At each station there's a stack of papers, a pen, a towel to rub your balloon on, and then what you're going to try and do it on. Okay? If you need any help, I'm going to be right there in that little area. Just ask a question real quick. I'm more than happy to help you. So you ready to go experiment? Okay, let's go. What I need you to do is each of you look at the piece of paper that's here and use the very first pieces and put your hypothesis. What do you think is going to happen when you rub the balloon with your towel and put it over what's in front of you? So can you write that first? What do you think is going to happen? Yours right there. What do you think is going to happen? Right up there. Yeah, right there. You don't have to worry, it doesn't have to be neat, it doesn't have to be perfect. Just tell me what you think is going to happen and let me know if the pen doesn't work. I'll grab you another one. Done? Okay. Then what I just need you to do is go have at it. You're going to use the balloon, rub it, and then do that. You're going to do it 3 times. Make sure you rub it really, really good, okay? Now we'll put yours right there on top. And then after each time you do it, tell me what you see. This is your trial 1. What do you see? Do you see more pepper? Do you see more salt? What do you see? So now what you want to do is maybe you want to count these to see how many you get each time. Like maybe rub it harder the next time to see if you pick up more. So you want to put down there, how many squares do you have?
I got
Oh, you got 9. That's so cool. What do you think's happening? Based on what we said, and here, you know what? I'll bring this in here. So you can look at this. What do you think is happening? Just think about that as you do it, and just write. What did you get more on? Because I know you can't count all that salt, but is there more salt or is there more pepper? What is it? Go ahead, right there. How many did you get? Put it there.
Yeah, they use about 3 hours. Wow.
Right there. And you want to take them off? Try it again. See if you can get more. See how much more you can get, or if you can get more. Right there. This one's right there. How many you got? And then take them off and try it. Oh my goodness. You got a lot more that time. Here. Hold it still and count them. Now, this time, try to rub it really, really hard and see if you get a whole lot more salt. What? Oh, wow! Oh my goodness, do you see that? That is a lot, isn't it? You know what we should do? We should have got a measure. Remember, we tried 3 times. That is a lot of salt. How long do you think that is? How many inches do you think that is? Maybe 3 inches? It's a whole bunch. But what is more? You have more of. More salt. Why do you think that might be? Can you write that here? Why do you think you got more salt? Remember, I've got this right here. So you can look back at it. So remember what we talked about. Got it? Can you hold that for you? Okay, cool. So, and then write your results. Tell me about it. Write about your results. What happened? Here. It says, what did you observe about the effect of the charges on the movement of the object? So in your case, what did you notice? What did you notice? Can you tell me what you noticed? What did you notice? So when you rub that towel, then it got a charge. Okay? And the salt did what? Attracted to it. So that means that did it have the same charge, or did it have a different charge than the balloon? Did it attract, or did it separate? Was it attracted to the balloon, or did it go away from the balloon? It was attracted to the balloon, right? So what does that show? That shows that the balloon had one type of charge, like positive, and then the salt had a what? Negative charge? Because they attracted each other, right? Okay, let's write that. Yeah, the object in this case is the salt and the pepper. So what is the effect of the charges on the movement? So the charge made them what?
Stick.
To.
The balloon.
So it was attracted to the balloon. So that's good. You're doing good.
What your favorite?
So you're acting like scientists right now because you're writing down your data of your experiment. You guys spelled balloon wrong. B-A-L-O-O-N. I spelled it wrong. I think I spelled it right. It's a miracle. Okay, just let me know when you're done. And you don't have to worry about spelling. I know that that spells balloon. They're good. These two are still writing, so as soon as they're done, we'll go in a circle. We have to try something else next. What did you do? Very good. What type of stack? Was it two positives? Or was it a negative and a positive? Any questions? You doing good? You're doing
Yeah,
good.
I have one question.
One question. What's your question?
Is it A-R or A-R for George?
A-R. It's okay. I'm not going to check your spelling.
Is it E?
Yep. E-F-E-N. Okay. So I do two people that are ready. So if you can, keep your paper. Keep your paper and take it to the next place. Keep your paper. And take that paper with you. So I want everybody to have all their papers because we're going to share our results. Everybody's results. Okay. Dedrick, you come over here, sweetie. There you go. Okay, so now that you've each had a chance to go to each station and experiment and write down the results, I want everybody to share one thing with me. So if you would like to share the Rice Krispie data with us. Dedrick, come on up. Okay, so what were, you fill in your three that you got? You scream. Please. What was your three? 9.
21
Wow.
and 20.
Okay, so Dedrick's results, the first time he got 9, the second time he got 21, and the third time he got 20. Okay, that's good. Okay, which one of you guys like to share paper? Come on up. Paper. Write down your results, your first, second, and third tries.
10.
3.
26.
Wow, that is a big jump from the first to the end. And can you come up and share the salt and pepper? You can put on that, what did you get more of? Salt or pepper each 3 times?
Salt.
Salt, okay. Write that down. Okay, that's fine. Okay, so because yours is salt, did you get like a small area of salt, a medium area of salt, or a big area of salt? Medium each time, or did it differ? Medium most of the time? Okay, so I'm going to put over here medium amount. Okay, so here were your results. Did anybody get different results when they did this? Did anybody get different results with Rice Krispies? Did anybody get a lower number than 9? What was your lowest number?
1.
That is a lower number, so we have a lowest number of 1. What about you? What was your highest number with the Rice Krispies? Can you tell me what your lowest number was? Your lowest, no? Let's see, what is that lower? You see, your lowest number is an 8.
What is the highest? My last one.
No. So what's the highest that you got?
25.
25.
Oh, man.
And what was your highest that you got with the Rice Krispies? 9. Okay. So, well, let's go on to do some more. So, what what were your results? What was your highest and lowest for the paper? The highest.
18.
18. Okay, and what was your lowest?
7.
7. What was your highest and lowest?
That's 8.
Yes.
I got 9.
9. What was your lowest?
21.
21 was your lowest? It sure was. Was that paper? I'm checking. Yes, we are. Paper. 21. And what was your highest?
27.
Okay. So we have a big difference here. We've got a low number of 10, 7, and 21, and a high of 35, 18, and 27. That's not bad. Now, with the salt, I know pretty much, did everyone pick up more salt? And did anybody pick up more of the pepper?
Like more salt.
More salt? One time you picked up more pepper?
2.
2 times. So we've got one person with 2 times more pepper. Okay, so let's look at this data. Because we've got a lot of different numbers here. We've got a 1, an 8, and a 9, and then a 21, a 20, and a 25. So that's a big range of numbers, isn't it? Why do you think at different times you got more or less of something? What are the factors that came in with it?
Negative.
Okay, yes, the negative and positive. Do you think it had anything to do with the balloon? Okay, why? Why do you think maybe you picked up more sometimes and a little bit less other times?
Because when you hold on the towel, the static sticks to the balloon.
Okay, so you had to rub the towel harder to get more static? Okay. What else? There's one other thing. You rub it harder and faster, but what else? You can rub it harder and
Soft.
faster. Not soft, because that's still in the harder. Not. I'm looking for a different word. Did you do it a long time, or did you do it a slow? Longer. So you also had to rub the balloon for a longer amount of time. So when you rub that balloon for a longer amount of time, it had more static. Because why do you think that is? Because you're rubbing that balloon longer. You're taking more time, and you're still rubbing it, and you're still rubbing it. So what's it doing? It's picking up
Static.
or more charge. The longer you do this, the more charge you get. And that way, that means that you're going to attract more of the opposite. So that's why you're picking up more things. Okay? So you have to rub it harder and longer. So if I just did this, so you got all the charge off, right? I'm just going to do it, and I just swipe it one time. So I'm going to pick up more or less?
Less.
Less. So if I wrote really hard and for a really, really long time, it's going to pick up more of my hair or less?
More.
Let's see. Yep. See how, look at that. Guys, so the reason all of these things were picked up by the balloon is because they had opposite charges. The balloon either had a negative charge to it, and then the things that we picked up had a positive. So that's why they were attracted to each other. Remember, opposites attract, and things that are like repel each other or separate. Okay, so now we're going to talk about another thing that static electricity can do. Okay, so what's this?
A light bulb.
A light bulb. Do you guys know how light bulbs work?
Yes.
How do light bulbs work?
Like when you plug it up,
You plug it in.
switch.
Okay. And it turns on.
Don't the electricity go somewhere through the thing,
Through the.
and then it touches that and light it up.
So the electricity goes through here and that makes the bulb light up, right? Okay, so now we're going to do the really cool experiment. And we're going to see if we can make this light bulb light up with a balloon. You don't, your hypothesis is no. Okay, this is good. I forgot pens. Here we go. So, this is our next thing. Let me grab pens. I should have grabbed them.
I don't think it will light up.
Talk about it.
I think it will.
What do you think's going to happen? Talk about it.
Maybe.
Talk about it. What's going to happen?
When you rub it, the charge part is gonna go through the bottom of the light bulb, and it's not gonna light up
It's not going to light up. Why do you think it's not going to light up?
because wires are not plugged into it.
Because there's no wires plugged into it. That's good. So write that down, please. That's your hypothesis. What's your hypothesis?
I think it was like a static, it was charged and go to light and charge. Or
Okay. Where do you think you would have to put it on the light bulb? Where would you have to put
the
balloon?
bottom.
The bottom? Okay, that's your hypothesis. We're going to see because we just don't know. I have no idea. This is an experiment. What's your ideas? You don't know. We heard their ideas, but you come up with your own idea. Or choose one of theirs. Do you think it will work or it won't? I don't know who she think. Just go ahead. Okay, so first thing we're going to do is we're just going to see if it works or not. I've got the light bulb here. Do I have a volunteer? And you're each going to have a chance to do this, okay? Each of you are going to have a chance to do this. So, Dedrick, go ahead and rub. So what do you, to get a really good charge, we want to do it what?
Fast.
Fast
Still hard.
and fast, long, and I just gave it away. Fast and for a long time. Okay, now we know where the electricity goes into the light bulb at the bottom, so I want you to hold it. Let's try it again. Do it harder. Maybe it's that type of balloon. Yeah, you got it, okay? Okay, so this is what I need to do. Long and hard like that. Okay? And then we need... did you see that?
Yeah.
Did you see that? What did it do? Okay, so now you try it.
I will only
Okay, yeah, do it on the end. Oh, it did it. Did you see it? Okay, it'll give you a try.
I bet
Next
I was
person.
wrong.
Yeah. But what's important is it important that you're wrong or that you experimented and had fun doing it.
Experimented and had fun.
And now you've got the answer. You can actually light up a light bulb with a what?
Blue.
That's what?
Harder and faster.
Right, harder, faster.
Oh,
so cool!
I didn't see that.
Did you see it? No, you didn't. You missed it. Okay, it's your turn.
Yeah,
So
but-
then you'll see it.
No, I wanted to see light up like the whole time.
Mm-hmm. Did you see that? That's cool. Isn't that cool?
Yes.
So what's happening? The charge that you're when you're rubbing it hard and long, it's picking up extra
Electricity.
electrons, right? And then you're transferring it from from the balloon
To
it's
the
going
light
on
bulb.
and making it what?
Light up.
Mm-hmm. Okay, so what we're going to do now, we're going to try to see if we can get Miss Melvin to help. Can you, we're going to try one. I don't know if this is going to work because it kind of is really super fast. One, so we touch the balloon to it and then stop it after it's off. Can you do that?
Yes.
So I need a volunteer. I want one of you guys to hold it because you can see that holding it doesn't hurt you. But you got to kind of hold it so we can see it. You want to go first? Since you went last, the last time you go
No, when you
first
want-
this time. Just when it touches. As soon as it touches and then when it goes off. Oh. Did you see that? What happened? Look, it's
still
still,
turning
it's still doing it, isn't it? Because there's what? There's still
Electricity.
static electricity on the balloon. There's still a whole lot of extra charges on there. Okay, so now do you want to hold it and you can charge it? Oh, look. Move it around, move it around. You see? Look. So it's picking up the negative charges that are still in the balloon, and it's still lighting it, isn't it? Move it around. Isn't that so cool?
Yeah.
Isn't that neat? Okay, so you guys have each had a chance to hold it.
This is time.
It's your turn, and I'm going to do it while you hold the balloon. How's that? I mean, while you hold the light bulb. So you get a chance to hold it too.
This is fun.
Keep going. Okay, ready, Melvin? Look, it's still doing it.
Oh.
Look as we move it around.
Oh.
See?
It halfway light up almost.
Uh-huh. See if we got, oh, so okay, so it stopped lighting, so what's that mean? We got all the what?
Static electricity.
We got all the extra charges that was on that balloon. Would you like a chance to hold the light bulb while I do it? Let's see what Miss Esworthy can do. I'm going to move this balloon around to see if we can get static all over it. What do you think? Extra charges all over the balloon. Okay, let's see what this does. Oh,
I wanted to light
some
up
there, one there, some there. We got some extra charges. That's so cool. Oh, look, did you see that?
Yeah.
It was still going. Okay. So what was our longest time? Like 10 seconds? So that's not bad, is it?
Nope.
Okay, so let's go out there and let's talk about what we saw in here. Okay, so how cool was that?
Cool. So cool.
Did it work every single time?
No.
No, because it didn't work which time?
The
The first time it didn't work at all, did it?
No.
Why do we think it didn't work?
Because we didn't rub it fast enough.
Not only did we not work it fast enough, but what else do you remember? What else we didn't do? Where did we put the light bulb?
Oh, we did this side.
We put it on the wrong side. I hadn't even thought about that. So that tells us that after, and what else happened when it worked?
Oh, we put it in different places in the light.
Yes, we put it different places in the balloon where the balloon was holding those extra charges. Okay, what else? The one time we actually saw something very bright kind of quickly. What was that? Like
Flash.
a flash. Okay, so that flash was the charge leaving the balloon and going into the light bulb. So we know that the balloon has extra charges on it, and they're opposite of the charges that we got, that were the opposite of the charges in the light bulb. Where's my light bulb? Okay? So the charge, when it went, it did the shock, and what did it do? It went where?
It went through the bottom.
Yeah, because we put the bottom on the balloon where the
The electricity is static.
exactly, and that made the bulb light
Light
up. Now, and what we found was cool because I kind of thought that my hypothesis was that when we stuck with the light bulb on the balloon, we were only going to light up it once. But what did you guys say we learned?
Electricity is static.
Yes, but what happened when we moved the bulb around the? It still lit up other places where we had rubbed that balloon. So the more we moved that balloon and rubbed it and got the extra charges all around it, the longer this lit up, right? What's your question there?
But it didn't light up all the way. But why is that you plugging the water and it'll make it light up all the way?
That's a very good question. Let's think about that. When we plug it in, when we've turned it into the socket, it's got a steady, continuous supply of what? Not water. What is it? Not
Electricity.
Oh, just regular electricity. So if it's got a steady supply, whereas when we rubbed on the balloon, we only got so much
Light.
Oh, we only got so much light, but why? Remember when we rubbed the balloon, it got extra charges, right? And so what happened when we moved that around and it transferred to the light and made it light up, very good. So what happened to that charge? Is it still there or was it used?
Used.
It was used, very good. Okay, well, you guys have any questions? But that was a good question, Dedrick, that was a very good question. That's a good question. These questions are good. Did you guys have fun?
Yes.
Did
Yes.
you learn a lot about static electricity?
Yes.
Okay, well, I'm glad. Thank you so much for helping me today. I appreciate it.
You're welcome.